video, I would like to tell you and actually also show you something about Active Directory tier model. Because tier model is a very effective way how you can protect your Active Directory, and especially how you can protect your most privileged assets in your Active Directory. Very often, when I come to a customer, I see that the Active Directory environment is not secured properly. Because by default, Active Directory, there is no separation between privileged identities or privileged devices and unprivileged identities or unprivileged devices. And that's a huge problem. This problem is not so huge in cloud environments. So for instance, if you have your devices joined to Microsoft Entra ID, then it's not so a big problem, but it is a huge problem for on-premises Active Directory environments. And on-premises Active Directory environments are still very common for many, or I would say even most organizations, and for good reasons, because they have systems connected to it. They have applications connected to it. They have a lot of backend infrastructure that they need to manage, which they cannot manage from the cloud. So they need something locally available for their local infrastructure. And so they need usually Active Directory and group policy objects to manage the on-premises infrastructure. But the problem is that there are usually not strict boundaries between privileged assets and unprivileged assets, which makes it then super easy for threat actors to compromise the environment completely. Imagine a situation where a regular user account is compromised or regular user device is compromised. In general, it shouldn't be a big deal, and it happens actually quite normally. It's not so big deal. Users click on some malicious link, fill in their credentials on phishing website, or download some malicious code and execute it on their devices, and their device or their identity is compromised. But this should not negatively affect the whole environment. There should be strict boundaries that would stop the threat actor from moving laterally to other assets, more privileged assets. So there should be some boundaries that would stop lateral movement and elevation of permissions. But there's usually not such boundaries in real for many organizations. And that's the problem. And that's the thing that I would like to talk about in this video. The way how you can create boundaries in your environment in Active Directory is called tier model. Tier model consists of 3 tiers: tier 0, tier 1, and tier 2. Tier 0 is the crown jewels. Those are the most privileged assets, most sensitive assets in the environment. So in tier 0, there are domain controllers. There are other identity systems such as Microsoft Entra Connect Server or Azure AD Connect, Microsoft Identity Manager, ADFS, or other systems that are responsible for user authentication or user management. These systems need to be extremely well protected, which means these systems should belong to tier 0 because this is the most protected tier. From user accounts, these are domain admins, enterprise admins, schema admins, obviously. Tier 1 is the regular backend infrastructure. So your regular servers such as file servers, database servers, application servers, and so on. And of course, the accounts that have access to these servers. And then tier 2 is the end user tier. So there are the end user workstations, end user accounts. That's the tier that's the least privileged and least sensitive in the organization. And there must be strict boundaries between each tier. So if there is something compromised, if something happens in tier 2, which is the most common case, because there are the regular user identities and regular user devices, the threat actor must not be able to move to tier 1, let alone tier 0. The threat actor must be 100% isolated in the tier that the threat actor compromised. There must be no way how the threat actor can move between the tiers, which makes it almost impossible to really cause serious damage to the organization. Because if the threat actor compromises a regular user account or a regular user device, the worst thing, the very worst thing that can happen is that end user devices will be affected. But the servers, the backend infrastructure must not be affected at all. Tier 0 devices such as domain controllers and the most privileged accounts must not be compromised at all. How to build the boundaries? Well, as you can imagine, there needs to be strict restrictions on who can use what and from where. So the accounts that belong to tier 2 can be only used on tier 2 devices and nowhere else. And the same with tier 1 and same with tier 0. So as you can imagine, this creates a little complication for your administrators, because it means that your administrators will need to have more accounts. If it's a smaller organization, the administrator typically manages everything, and in such a case, the administrator needs at least 3, probably 4 accounts, or maybe even 5. Why? Because the administrator needs a tier 0 account to manage the Active Directory itself. Then the administrator needs tier 1 account to manage the backend infrastructure. Then the administrator needs tier 2 account. Obviously, that would be the regular user account. But the regular user account should not be privileged even in tier 2. So there should be another tier 2 privileged account that's administrator on tier 2 devices. So it's 4 accounts. If the environment is hybrid, then there should be another privileged account for the cloud environment as well, which makes it 5 accounts overall. So it's complicated, or it creates complications, but it's very important because it stops a potential threat actor or isolate the threat actor in one tier so that the threat actor cannot affect other tiers as well. I mentioned that devices within a tier can be accessed only from accounts that's from the same tier, which means that the administrator will not have only 5 accounts. The administrator will have also 5 devices, and that makes it super complicated. But there are ways how you can avoid having 5 devices for each of your administrators. You can use something that's called, for instance, jump boxes. So in general, the devices that are used to manage something are called privileged access workstations, or in short, PAWs. You don't necessarily need a PAW for each tier. So maybe you can have a PAW for tier 0 because that's the most sensitive tier, and then on this PAW you can virtualize PAWs of other tiers. So you can have then virtualized PAW of tier 1 and PAW of tier 2 on the same device. There is one very important rule, which is that the device that is used for virtualization, the physical device, must be the most sensitive tier that's used. So you cannot have your regular device, which is the regular device in tier 2, and virtualize on the device a port for tier 1 or tier 0. It needs to be done the other way around. So you can have a POE, physical POE for tier 0, and on top of it, POE for tier 1 and tier 2. That's fine, but not the other way around. And that's the question that I usually hear from my customers. Like, hey, okay, so we will have a regular admin workstation, and on the workstation, we will virtualize our POEs for all tiers. No, that's not secure. The reason for that is that if the physical device is compromised, it means that the threat actor controls the device, which means that the threat actor controls also the virtualized environment on the device. So you need to have it like that the physical device is the most sensitive tier, and on top of it you can have less sensitive tiers virtualized. Or you can use something like Azure Virtual Desktop for management. And that's quite a common scenario as well. It's called Jumpbox or Jump Host. So it's a dedicated device that's been virtualized, for instance, in the cloud. It's a virtualized pool, let's say, that's shared by multiple administrators. So it's one Windows server, for example, that belongs to tier 1, and this tier 1 server is used as a jump box or as the virtualized pool for multiple administrators that are managing tier 0 or tier 1 in this case. So that's also possible. But don't forget, you need to have a pool or jump box for each tier. You shouldn't share it across multiple tiers. The problem with virtualization also goes to the core infrastructure. So let's say that you have your domain controllers virtualized, which is quite common. It's fully supported, there is no issue with that, and it's very common. But from what I've said, you should already know that you cannot virtualize domain controllers or anything other than tier 0 hypervisors, because domain controllers are tier 0. As I said, the physical devices, the hypervisors, must be the most sensitive asset. So if you virtualize tier 0 devices on top of it, the physical device must be tier 0 as well. Because normally your hypervisors are probably, or in most cases, it's tier 1, because it's used to virtualize tier 1 infrastructure. It's just some backend infrastructure as well. So most admins think, okay, this is tier 1. Hypervisors are tier 1. Yes, in general, hypervisors are tier 1. But if you virtualize tier 0 devices on those hypervisors, then the hypervisors must be tier 0 as well. Another thing that's quite often misconfigured or overlooked is Exchange. Because Exchange by default, by its definition, is tier 0. But it shouldn't be tier 0 because it's accessed by end users, it's exposed to the internet. It shouldn't be tier 0. It should be tier 1. But it cannot be tier 1 because it's used also to manage accounts, to configure accounts. It manipulates with the objects in Active Directory. So from the definition of tier 0, Exchange should be tier 0 as well. But it should be tier 1 because it's accessed by users, it's available from the internet. And that's why we have something that's called split permission model. It allows the Exchange to be both tier 0 and tier 1. So the tasks that are related to account management belong to tier 0, where the Exchange services itself are tier 1. It needs to be configured. It's not there by default, but it can be configured. It's very well documented by Microsoft. It's official thing. So you need to think about it and you need to configure it. Split permission model for Exchange if you have on-premises Exchange. Another thing that's worth mentioning is WSUS, Windows Server Update Services. If you use WSUS in your environment to distribute updates, you need to think about the tiers as well. Normally, WSAS would belong to tier 0. When it belongs to tier 0, it can service tier 0, obviously. It can also service tier 2. Oh, sorry, when it belongs to tier 1, because it's an infrastructure server, it can service tier 1. It can also service tier 2, because it's lower tier. But it must not service tier 0, because it's a tier 1 device. If the tier 1 device is compromised, the threat actor may distribute malicious updates to domain controllers and take control of domain controllers via WSAS. So when you use WSAS in your environment, you should preferably have two WSAS servers. One WSAS for tier 1 and tier 2 that will belong to tier 1, and then another dedicated WSAS for tier 0. And the same goes also with SCCM. It's also very common. SCCM is typically shared across the environment. All devices use one SCCM instance. It shouldn't be configured this way when you have tier model implemented. There needs to be a dedicated SCCM for tier 0, and then typically another SCCM for tier 1 and tier 2. It can be shared. Sometimes for large organizations, it's beneficial to split it even between tier 1 and tier 2, but at least you should have dedicated SCCM for tier 0. So these are the most common examples of things that you should think about. For the hypervisors, it's not only about Hyper-V. VMware is actually very often target for threat actors. So if you use VMware and you virtualize domain controllers on your VMware infrastructure, the VMware infrastructure, the complete infrastructure, all components of the VMware infrastructure must be tier 0 as well. How you then execute the plan in practice? So I open Active Directory users and computers in my lab environment. First, I have this admin OU here. There is OU staging. The staging OU is used for newly onboarded devices to Active Directory. Then we have tier 1, tier 2, tier 0, tier 1, and tier 2. Tier 0 accounts, these are typically domain admins, schema admins, and enterprise admins. I have this one account, which is the RID 500 account. That's the built-in admin account. And I also have my own account that I created later on for the normal Active Directory admin tasks. If I open the account, you can see that it's member of domain admins. So it's the most privileged account. It's a tier 0 account. Admin workstations are the tier 0 POS, the admin workstations, physical POS or jump boxes. Tier 0 groups, computers, operators, service accounts. All tier 0 devices should belong to tier 0 computers group, because we use the group then in user rights assignments. I will talk about it later when we get to group policy objects. Tier 0 operators are local administrators on tier 0 devices. If you are a larger organization, you may have domain admins, enterprise admins, schema admins that manage Active Directory, and then you may have different people who actually manage the infrastructure for it, like the tier 0 servers, tier 0 POS, tier 0 jump boxes. So these administrators of the infrastructure, tier 0 infrastructure, will be members of this tier 0 operators group. This tier 0 operators group is local admin on tier 0 devices, but these members don't have any Active Directory permission, so they are not domain admins or enterprise admins or schema admins. And last, obviously, service accounts. So these are all service accounts that belong to tier 0. It can be service accounts for Microsoft Defender for Identity, SCCM, Microsoft Entra Connect server, and so on, or SQL servers. In general, any account that needs to have logon as a service permissions on tier 0 devices. Then tier 0 servers, we have some sub OUs here as well. So the backup infrastructure for tier 0 must be tier 0 as well. Database servers, identity servers, these will be typically ADFS or Microsoft Entra Connect server. Tier 0 management, this can be WSAS, for example, or SCCM. PKI, obviously, and certificate authorities. And virtualization, so Hyper-V hosts or VMware hosts and so on. And then the service accounts, OU for service accounts itself. We have almost the same or very similar structure for tier 1 and tier 2 as well. Then we have some dedicated OUs for computer quarantine. So simply computers that are being decommissioned or are isolated from the environment for whatever reason. Built-in OU for domain controllers, custom OU for groups, and custom OUs for tier 1 servers and tier 2 devices, and for user accounts as well. But this is not so important. So it doesn't have to be configured this way. This is just some general recommendation how it may look like. But in a real environment, it will be configured probably differently. But what's important is that we have this admin OU where all the admin part is. So the admin accounts for everything for tier 0 and admin part for tier 1 and tier 2. So the privileged accounts for tier 1 and tier 2, privileged access workstations for tier 1 and tier 2, and privileged groups for tier 1 and tier 2, and potentially service accounts. So this is the general structure in Active Directory users and computers. Now we can get to group policy. So I have this default domain policy here. You should never touch it. Don't change anything in it. Same goes with default domain controllers. Policy, don't touch it, don't change anything in it, keep it default. Create your own GPOs if you need to change something, and then make it higher priority than the default policy. But let me expand this. I have super simple structure of GPOs created here. I have 4 GPOs for tier 0, 2 for tier 1, 2 for tier 2. Domain block top level simply blocks access for anything that belongs to tier 0 to anything other than tier 0. This GPO would be linked to the root of the domain, and because the admin OU have inheritance disabled, it will be applied to everything except for the admin, and in this case also the computer quarantine, because inheritance is disabled. So it will be applied to all other OUs except for the admin OU, which is intentional, because as you can see, the only thing we define is deny permissions for the tier 0 assets, like the schema admins, enterprise admins, account operators, tier 0 operators, tier 0 service accounts, and so on, that the most privileged groups that are there. So we define deny permissions, which means it will be denied everywhere except for the OUs with disabled inheritance, which is this admin OU and computer quarantine OU. So this ensures that tier 0 accounts can be used only in tier 0 and nowhere else. Even if you try to use the account somewhere else, you will see the block message that says that this account cannot be used here. Domain controls policy is a simple policy that should be linked to the domain controllers OU, and it defines who can use domain controllers and how they can use it. So for instance, that logon as a service is defined for the tier 0 service accounts. That's the reason why we have the group there. Then we have some general recommended configuration for domain controllers, but that's not important for the tier model. Next policy, tier 0 restricted groups and tier 0 user rights assignments. These two policies are then the same way configured also for tier 1 and tier 2, with just different permissions. Restricted groups simply defines who is a member of the local built-in administrators group. So simply users that are local administrators on the devices that belong to the same tier. So for tier 0, obviously it's the group tier 0 operators. Same as for tier 1, tier 1 operators. Tier 2, tier 2 operators. And then we have the user rights assignments. This simply defines who can do what. So we see some allow and also some deny permissions. Allow permissions are simply defining what the users can do in the tier. So for tier 0, we have allow for tier 0 groups. So like tier 0 operators, but we have deny for everyone else. Tier 2 operators, tier 1 operators, and other permissions as well. And the same is for tier 1. See some allow permissions here and deny permissions, and the same tier 2, allow permissions, deny permissions. So it's a very simple structure that defines the boundaries between the tiers. As you can see, it's really enforced, and that's very important, because sometimes when I ask customers if they have tier model implemented, they say yes, we have tier model implemented. We have dedicated accounts for tier 1, tier 2, tier 0. They have the OU structure created, but it's not enforced. So even though they have dedicated accounts for tier 1, tier 2, and tier 0, it's not enforced. Technically, it's still possible to use, for instance, their domain admin, which is obviously tier 0 account, on any device in the network, because there is no restriction in place. So these restrictions are super important, super important. It must be enforced. If it's not enforced, it's not applied. It doesn't make any sense then to have or to even say that you have tier model when it's not enforced, because the administrator can still use the account intentionally or unintentionally on other tiers, and then the account can be compromised by a threat actor because the cache credentials are there, the hash is there, they can use it, they can break the hash, or they can use the hash directly for pass the hash attack, and so on and so on. So it's very important to have it enforced in your environment. That's all from my side for today. I hope I explained it understandably. If you have any questions, let me know in the comments or contact me directly. You know my email. It was in the welcome email when you register or sign up for the videos. So contact me directly if you need some details. If I didn't explain something correctly, or you didn't understand it well, you want to talk about it, let me know. If you like the video, please like the video, share the video with your friends, with your colleagues, with your employer maybe. So share it. Don't forget to follow my Cybersecurity World blog. Also, you can follow my personal profile on social networks such as LinkedIn, Twitter, Mastodon, Blue Sky, or Threads. And that's really all from my side for today. Thanks for watching, and see you next time.